In this lesson, I am going to show you how to convert from log form to exponential form, from exponential form to log form, evaluate logs, and then evaluate logs using the change of base formula. So a log is another way of writing exponents. Okay, so here are the two forms. So the first one is in log form. Okay, so as you can see, log, the b is the base, okay, the x is the exponent, and then that's going to come out to a. So if you go from log form to exponential form, as you can see, okay, the b is the base for this exponential form. Okay, the x is the exponent, so if you take b to the x power, that is going to come out to a. Here we read in log form, okay, log base b of a equals x. So the b is the base, as you can see here in exponential form. The x is the exponent, so b to the x power equals to a. So here's the first example. It says to write the equation in exponential form. Okay, so you're given in equations in log form and you have to convert it to exponential form. So here's the given example. Okay, so if you have log 6 of 216 equals 3. Okay, so what would this be in exponential form? Well, in exponential form, the 6 is the base, so it's going to be 6. The 3 is the exponent, so it'll be to the third power. Well, 6 to the third power is 6 times 6 times 6, 3 times, and that is going to give you 216. Okay, so this is your exponential form, and then this is your log form. Let's look at another example where you have to change from log form to exponential form. So here you're given log base 9 of 27 is 3 over 2. And we want to convert this to exponential form. So the 9 is the base. The 3/2 is the exponent. Okay, so 9 to the 3/2 is the same as 27. So you end up taking square root of 9 to the third power, which is 27. Here is example 3. It says to write the equation in log form. Okay, so here we are going from exponential form, given, to log form. So the given exponential form is going to be 3 to the 4th power is 81. What would this be in log form? Okay, so we know that 3 is the base, so it's going to be log base 3, so the 3 goes down here. And then 81 is 4. So log base 3 of 81 is 4. So these two are the same thing, but one is in exponential form and the other one is in log form. Let's take a look at another example where we go from exponential form to log form. So here is the given exponential form. Okay, so if you have a to the 4 over 3 is 16. This is your exponential form. Okay, what would this be in log form? Well, it's going to be log. Okay, your base is 8. That's your base, so log base 8 of 16 is 4 over 3. Okay, so next we're going to get into common log. So common log is a log with base 10. Okay, it's called common log, and it can be written without the base. Okay, so here you got log base 10 of x. Okay, it's the same thing as log x. Okay, when you don't have a base, see there's no base here, you have to understand that it's base 10, okay? So this right here is common log. So when you see log x, you have to understand that it has a base of 10. Okay, so let's take a look at example where you have to use your knowledge of exponent to evaluate the given log. So here you're given, okay, so here you're given log base 3 of 27, and you have to evaluate this. So we are looking for the exponent, so that's what we're going to call it x. So 3 to what power give you 27. Because we know how to convert this to exponential form, we're just going to quickly do it. So 3 is the base, x is the exponent, and then that comes out to 27. Okay, so 3 raises to what power give you 27. So your x here is going to be 3. So 3 to the third power is 27. Let's take a look at another one. Okay, so here we have log base 12 of 1. Again, we're looking to evaluate this, and we're looking for the exponent. Okay, so 12 to what power x is 1. Okay, so 12 raises to what power is going to give you 1. And we know that x is going to be 0 because any number to the 0 power is going to be 1. So x is 0. Okay, let's take a look at another one. So here we got log base 3 of 243. Again, we are going to evaluate this log. Okay, so we're going to set it equals to x. So now we're looking for the exponent. Okay, so it's going to be 3 to what power is going to be 243. Okay, so what is the value of x here? So in this case, x is going to be 5. Okay, so because 3 times 3 times 3 times 3 times 3 5 times is going to give you 243. Okay, so let's take a look at one more evaluating log. So here log of 64 is 4. Okay, so we're going to evaluate this. So we're going to set it equals to x, and we're going to find out what x is. So in exponential form, this would be 64 to the x power is 4. If you cannot figure this out in your head, what we can do is rewrite 64 with base 4, and we know how to do that, right? So here to rewrite 64 with base 4, so that is going to be 4 to the third power. So 4 to the third power is 64. And then on the other side, you get 4 to the first power. Okay, so this is 4 to the 3x. And then this is 4 to the first power. And now you can drop the bases. And then you set the exponent equals to each other. So that would be 3x is 1. Okay, and then divide by 3 to get x. So divide by 3, divide by 3. So your x is 1 over 3. Okay, and then 1 over 3 is the same as cube root. So if you take cube root of 64, okay, you get that 4. Okay, so now I am going to show you guys how to use the change of base formula. So some log are not easy to evaluate as those that we did earlier, and will require the change of base formula. Okay, so here's what the base formula is. If you wanted to evaluate log base b of a, and you needed a calculator to evaluate it, this is how you would set it up. Okay, so you would take log base 10. You see there's no base, so that means it's base 10. And you can punch that into the calculator. So log base 10 of a, which is the same as log a, divided by log b. Okay, so you can punch it into the calculator. So if you have a log problem that you needed to evaluate and you cannot do it, okay, without using the calculator, because it's going to come out to a decimal number, you would have to use the change of base formula. So you can punch it into the calculator, and that's going to give you the answer to it. So let's take a look at some examples here. So here we're going to look at examples of how to evaluate using the change of base formula. So let's take a look at this one. So here you have log base 8 of 32. Okay, so we're going to evaluate this. So we're going to set it equals to x. Okay, so if you were to convert this to exponential form, it would look like this. It would be 8 to the x power equals to 32. Okay, so now to solve this exponential form, you would have to rewrite the 8 and the 32 to the same base and then drop the bases. But in this case, we're not going to be able to do that. So that's why we needed that change of base formula to evaluate. Okay, so to evaluate this, you would have log base 32, so the 32 is the a, so that goes up top. Okay, and then divide by log 8. Okay, and then you punch it into the calculator. So I'm going to bring up a calculator to show you how to do it. Okay, so here is a calculator that you can get online. It's Desmos, desmos.com. Okay, so you can get this calculator online. Here we're looking to evaluate log 32 all over log 8. So I'm going to press the function key. So here's a button for log. See it right here? So go log and then punch in the number 32 and then divide and then go back to function and then press log again. So this time we need it to be log 8. As you can see, the answer is on the right hand side here. So it's 1.666 and so on. So we need 4 numbers after the decimal point. So that is going to be 1.6667. Okay, so here's going to be 1.6667. Okay, so that is how you evaluate log using the change of base formula. Okay, so we're going to look at one more example here. Okay, so for this example, we have log base 4 of 136. Okay, so we're going to evaluate this. So we're going to set it equals to x. We're looking for the exponent. 4 to the x power is 136. So 4 to what power will give you 136. So we're going to use the change of base formula here. So x is, so it's going to be log base 10 of 136. Okay, no base is base 10. And then all over log base 10 of 4. Okay, and then we're going to punch it into the calculator to get the approximation. Okay, so we're going to clear this. So here we have log 136 divide log 4. Okay, and then as you can see, the answer is on the right hand side here. It's 3.5437. the approximation for this is going to be 3.5437. And that is how you evaluate log using the change of base formula.